ISADS stands for Interactive Search Assisted Decision Support. The goal is to enable physicians to make more informed decisions about a given case by presenting them with relevant cases from a massive, distributed, annotated medical repository. Unlike systems that try to make decisions for physicians, ISADS is a tool that allows them to search and compare medical images, where the retrieval is done based on image content rather than text or metadata. One application we are currently developing is ISADS for melanoma detection. Melanoma is the most fatal kind of skin cancer, and the incidence rate has been increasing in the US. For this application, we are collaborating closely with physicians from the University of Pittsburgh School of Medicine.
In evaluating pigmented lesions on the skin, one of the tools that I use as a dermatologist is a dermatoscope, which is this handheld instrument here. And this is basically a form of surface microscopy that lets us get a deeper image into the mole that we can achieve with the naked eye. The reason that we do this is that right now the way that we detect cutaneous melanoma is by examining the patient in our office. If a mole is suspicious, it has to be removed, which involves anesthetizing the patient with an injection and cutting the mole out and sending it to a pathologist to be looked at. This obviously leaves the patient a scar and can be uncomfortable and does have some risk of infection. So what we're looking for is a way to non-invasively evaluate moles, and so dermoscopy is one way to do that. The difficulty with dermoscopy is that two moles look the same, and so we need to be able to make sense of the image that we get. One way to do that is to process that image and get some information about it, such as the size of the mole, how symmetric it is, and we also want to be able to compare the image of the mole that we're seeing on a patient in the office with images in a library of multiple moles, and see whether the mole that is in front of us looks like one in the library, and if so, what was the diagnosis of that mole, to give us a better idea of what we're looking at. And this is where ISADS for dermatology is a powerful tool. So if this is a patient who's in the office for evaluation of, let's say, this mole right here, the way that we would use dermoscopy is to clean the skin with a little alcohol, and I can use my eyes just to examine the mole. If we then want to be able to compare this mole to others in the system, we can take a photograph of it, and then we have a photograph of that dermatoscopic image, and we can download it into the system.
To develop an application for real clinical practice, we take care to make it fit into the clinical workflow. To achieve this, we streamline and automate the operation, as well as design the interface to be physician-friendly with just the right features.
Automated interpretation of medical images is challenging. From removing artifacts to finding lesion boundaries to extracting color characteristics, we develop algorithms that are driven by domain knowledge, employing statistical machine learning to keep improving performance.
This is the ISADS for dermatology application. Some of the tools that we provide for the dermatologists are a ruler, which they can use to draw on top of the lesion to get an idea of the size. As you can see here, it's about 5.5 millimeters. Other items in the toolbox allow you to turn on a border inspection, which shows you 8 segments of your lesion, symmetry axis, which shows you the primary and secondary axis of symmetry, and also a button that allows you to show the border where our algorithms segment the lesion. There's also a zoom feature, which allows you to get a closer look at the lesion in question by clicking on it and zooming in by some magnification level. And there's also a color histogram, which we generate, that shows the 6 colors that the dermatologists have specified that are interesting to them. So what we're going to do now is select a region that we're interested in on this lesion and do a texture-based search. We're going to go to the next screen, and we are going to select our search and initiate it. And you'll start seeing results that are being returned that have a yellow box selected within the lesion that have a similar texture as our source image. As your search progresses and you start to notice that maybe the results that are being returned are not exactly what you're looking for, you can make modifications to your search filters right on the fly and add more filters, modify the thresholds of each of the filters, and narrow down your results to find exactly what you need. The search that we've started right now has two filters involved. One is the texture search, as well as the blue-white veil visual feature filter. So what you should see being returned by the servers, one, the texture search, which is highlighted by the yellow box in the returned result. This texture in that box should be very similar to the texture that you've selected in the source image. Also, the returned images should contain a blue-white veil. By clicking on the lesion, you can see some additional properties. We have lesion properties that show the size, the diagnosis of the lesion, ABCD score, and other relevant information specific to that lesion. And as you can see, 70% of the lesions that have been returned based on the source image are malignant.
This collaboration with Intel has been very useful in combining people with clinical skills and people with computer science background and letting us use our very different skill sets to work together to try to solve a clinical problem. In my case, I'm very excited to be able to use this soon in the clinic because I think it will improve my diagnostic skills, and I think it will help me not only to detect subtle melanomas in my patients, but I think it's also going to help me to save my patients from multiple biopsies because I'll better be able to predict which moles are benign and which ones are malignant.